Welcome to qnawire.
The first thing that we have to do in this problem is find the radius of the first part of our space station, given that we know the angular acceleration that is desired at that point. In order to approach this, let's first make sure that all our givens are in terms of quantities that we can use, and the only thing that we have to really do for that is realize that our frequency of 1 rotation per minute means that our period must be 60 seconds, since period is the amount of time that it takes to complete one full rotation, and 60 seconds is of course equal to a minute. All right, so we're going to use period now to solve the rest of this problem. We know that t is equal to 2 pi r over v, which means that we can rearrange to solve for velocity, a quantity that we're not given in this problem. We also know that angular acceleration is equal to v squared over r. That means that we can plug in the quantity that we just solved for in order to solve for our angular acceleration. So we get alpha is equal to 4 pi squared RA over t squared. Now we know alpha A. We have a desired quantity that we want to get. We want to solve for r. So we rearrange to get that r is equal to alpha t squared over 4 pi squared. And in order to solve for r, all we have to do now is plug in. Alpha is 10 meters per second squared. T is 60 seconds, as we just found. And 4 pi squared is a constant. So our final result for RA is going to be equal to, after we round, 928. Oh, sorry, my bad, not 928, 912 meters. All right, so now that's our final answer for A, and solving for B is going to be really straightforward. We're given the ratio between the two radii at the beginning of the problem. So this means that RA is equal to 4B, and since we know RA, it's 912, we know that RB must be equal to 228 meters. There we go, that's your answer for B. All right, final part of the problem. We're asked to solve for the angular acceleration at point B, and this is going to be pretty quick too. Earlier, when we were working on part A, we found an equation for the angular acceleration. It's 4 pi squared RB over TB squared. The only thing that's changed actually is that the fact that we're using the radius at B. And I just made a mistake because the important thing for solving this is realizing that T is constant everywhere for an object, right? No matter, the object is always going to take the same amount of time to rotate no matter where you are. So when we plug into this equation, 4 pi squared times RB, which we just found is equal to 228 all over our seconds squared, which is 60 seconds, we get that our angular acceleration at point B is 2.50 meters per second squared, which is our answer for part